We're going to be talking a lot about graphs in this course. And so we're going to start out here by looking at some basic properties of graphs with equations of two variables. The solutions, if you look at equations with two variables, and here I have three examples, you could have anything, any combination of two variables. And we're going to usually use X and Y. The solutions to these equations are ordered pairs. They're combinations of X and Y. They're any pair of numbers that you would put in one in for X, one in for Y, that makes the equation true or solves the equation. And so you can have large lists of solutions, these ordered pairs. And so, for instance, if I take the equation y equals 3x minus 2, I can find a subset of the solutions using something we call an XY table. And really here you just plug in numbers for one of the two variables, and then you solve for the other one. So for instance, I might plug in some numbers for X and see what happens. See what I get out for Y. I could plug in a 0, maybe a 1. I just choose some things where the arithmetic works out nicely. Maybe 0, 1, 2, 3. Okay, pretty simple. And all I do is I plug the value in for X and calculate the Y. So I know Y is going to be 3 times 0 minus 2, order of operations. 3 times 0 is 0, minus 2 is just minus or negative 2. There we go. Plug in a 1, for instance. Try that for the X value. So Y equals 3 times 1 minus 2. Again, order of operations, multiply, then subtract, and 3 minus 2 is 1. So 1 comma 1 is the solution. Try a 2. Y equals 3 times 2 minus 2. 3 times 2 is 6. Minus 2 is 4. And let's try 3. So you do y equals 3 times 3 minus 2. That's 9 minus 2, which is 7. Okay. So we have some points that we can now put on the graph. And that can help us in finding the entire graph. Now the entire graph is going to involve all of the infinite number of ordered pairs that will solve this equation. I've only found 4 of them, okay? But even though it's 4 out of an infinite number of them, this 4 should be sufficient to give me a pretty good idea of what that graph looks like. Okay, so I'll set up a XY axis here. And I'll start plugging or plotting some of these. So I need a scale on my axes. So maybe in the X direction, I go out, maybe out to 4. And then we'll try a similar size scale on the left. I should really draw that longer. There we go. And maybe going up and down. Well, I got to get a little bit higher. Y value 7 is my highest value, so maybe we'll go up to 8 in the y-axis. Now, the scale doesn't have to be exactly the same, or the distances here on the two axes. Within an axis, you need the scale, you need the distance between numbers to be consistent, but the x-axis can be a little different than the y-axis. It doesn't really matter. So here I'll go with every other value. Good enough for now. And so I start plotting these points. Well, 0, negative 2, this is the point. I'll put the points over here on the left. 0, comma, negative 2, 1, comma, 1, 2, comma, 4, and 3, comma, 7. Those are the corresponding 4 ordered pairs. So I plot those on the graph. 0 is the horizontal direction, negative 2 is the vertical. So that's 0, negative 2. 1, comma, 1, you go over 1, up 1 from the origin. 2, comma, 4, you go over 2, up 4 from the origin. Roughly. It's a little bit to the right. There we go. That's not right. It can't be right. I'm doing something wrong. Oh, I know I did it wrong. 1 comma 1 is not a 1 comma 1. 1 comma 1, I have a 1 comma 2. 1 comma 1 should be 1 over 1 up. And 1 up is right there. I don't think that looked right. Okay, and then 3 comma 7. You go over 3 and up to 7. And there we go. Now in this example, the points seem to line up pretty well on a straight line. And in fact, this equation is what we call a linear equation because the variables all have powers of 1. And so we do end up with a line here. And typically with these, you can connect the dots essentially because every point in between will also be on a solution to this. And every solution will be on the line that contains these 4 points. Okay, so I'm going to go ahead and, missed. Plot the line. Of course, it's not perfect because my scale is not exactly consistent, but you get the idea. There's a line, okay? Now there's some other features of this line that I need to point out, particularly the intercepts. The X-intercept and the Y-intercept are 2 important points. And they can be found, there are X and Y-intercepts for a lot of different graphs, and if we can find those, that's a good starting point. To find X-intercepts, well, those occur when the Y value is equal to 0 in the equation, okay? And so an X-intercept occurs when Y is 0, because the height is 0 to hit the x-axis. And so then you plug that in to the equation. So you solve for x after you plug that in. So you 0 equals 3x minus 2. Add the 2 to both sides. 2 equals 3x. What am I doing? 3x. And then you divide out the 3 to solve for x. And you get 2/3. That kind of makes sense. That's roughly where that crossed at 2/3. Okay. So my x-intercept is the point 2/3 comma 0. Okay. The y-intercept is found in a similar way. You just plug the 0 in for the x value, which we've actually already done. So for the y-intercept, that's going to be the point where the x value is 0, and you then correspondingly solve for y. Okay, you always set the opposite variable equal to 0 to get the intercept. The y-intercept, of course, is the point where the graph crosses the y-axis, and at any point on the y-axis, the x value, the horizontal value, will be 0. And then you solve for y, which we've already done. You get y equals 3 times 0 minus 2, which is -2 when you solve it out. Okay? So 0 comma -2 would be our y-intercept. And you can find x and y-intercepts for just about any graph, as long as they exist. And so, for instance, the second graph, or the second equation, if I wanted to find the x and y-intercepts, we'll do the x-intercept. Actually, let's do this. Save myself some space here. I'll just do it underneath the other ones. So if I want to find the x-intercept, I let y equal 0. I end up with x squared plus 0 squared equals 9. I'm sorry, not x squared. It's just x. X plus 0 squared equals 9. 0 squared is 0. Means x equals 9. So my x-intercept is at 9 comma 0 for that graph. The y-intercept for the same one is going to be where x is equal to 0. So I have 0 plus y squared is equal to 9. The 0 is gone. Y squared is 9. We use the square root property here. And then y is equal to plus or minus the square root of 9, which is plus or minus 3. And so there would be 2 y-intercepts on this one. One of them being at 0 comma 3. The other one being at 0 comma -3. Okay? One with the plus, one with the minus. All right, and we can repeat the process for the other equation down here. Any equation to find the x, y intercepts is going to be exactly the same. The process is going to be the same. you just set the 0 in for the opposite variable and then solve for the variable that corresponds to the axis you're intersecting.